Alright class, in this video we're going to talk about the examples in the algebraic proof section. The only thing I changed here was, for this example, basically they're talking about just solving the equation, and the only real difference you notice here is that they put the properties along with it, which you'll see is really called the reasons in a two-column proof. So here the properties are simple. This is the original equation. Here we did distributive property to go from step 1 to step 2. Step 3 we did addition property because we wanted to get rid of the 6. Step 4, here it has substitution, but in reality is simplify, because all you're doing is simplifying the equation itself. And then here you just division, because that's how you get rid of the 3 with inverse operations. And then here just again is simplify, which is x equals to 16. Alright, let's move on to the next example. Alright, and this example is really a two-column proof. And a two-column proof, per definition, is just a formal proof where one side you have the statement itself and the other side you have the reasons. Always in any proof, whether it's a two-column or a flowchart proof, the first reason is always just a given statement, which in this case is here, and then the if statement. In other words, the if part of the statement is the given, and the then part of the statement, which is the conclusion, is where we put at the very end, is what we're trying to prove. So in this case, we have here given. So what's given? This equation. Now here all they did was distributive property. In other words, they multiplied 3 to x and 3 to 5 over 3. Now again, the substitution isn't something that I'm a fan of, so let's take that out. Let's take out the substitution, and let's take out this substitution. And then here what we're going to put is, again, simplify. We'll just put it here. Hope I spelled it right this time. There we go, simplify. And here we put also, again, simplify. And again, all simplify means is to make things simpler or easier to understand. And that's basically what we're doing. We went from 1 to 3, and then this is a lot easier to understand than this particular statement. And then from there, we add the 5 because it's subtracting, so that's addition property. That doesn't change. And then here, we simplified this statement to here, and then to move the 3, you divide. And then again, we simplified it all the way to here, which is x equals 2. And in this case, we're going to take this one out and also put simplify. Alright, this is just a simple two-column proof using algebra. This is just to get you in the idea of doing proofs. We'll do geometric proofs later, but for right now, the algebra ones I just want you to do so that way you can see how it works. Alright, let's do the next example, which I believe is, same thing. This is the same thing again. The given part is always the first statement with the reason given. Why do we have this? Because it was given to us. And then at the very end is, which is the prove part, or the then statement, goes here at the very end. And instead of substitute again, we just put simplify. So it's the same process again. So the only thing I would change here is just the substitution, reasons, and just put simplify. That's really what you're doing. You're simplifying the equations into something that's easier to understand. That's what simplification basically means. So here we put simplify to make this smaller. Well, not that small. That's good. So then simplify goes here. And let me just copy this. And then paste. And then let's take this. And this goes here for the reason for statement 5. And again, paste. And just put this here for 7. And again, paste and put it here for 9. And those are all the reasons there. Let me see. Oh, we don't need this one. That was a mistake. Alright, so we have for 5, we went from 4 to 5. This looks simpler, so we just put simplify. Here, this looks a lot simpler. We put simplify. We're not done because we got to divide by the negative, and then at the end, we put it to the simplest form, which is this one. N equals to -1. Alright, moving along. this we went over in class. This is one of those questions you might get on the test. They give you a diagram or illustration, and then they want you to determine whether these statements are valid. In other words, are they true? So this one, this reads, if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then which of the following is a valid conclusion? Well, let's see. Statement 1 says AB is equal to CD and CD is equal to EF. Well, the statement 1 is true based on the definition of congruent. Since these segments are congruent, then by definition they're equal. So the first statement is true. Now let's look at the next statement. It says segment AB is congruent to segment EF. Now that statement is true because of a property called the transitive property. And think about this. EF and AB are congruent to the same segment, which is CD. Since they're congruent to the same segment, which is CD, they both have to be equal to each other because they're congruent to CD. So the second statement is also true per the transitive property. And if you want a simpler way of looking at it, if AB is 4, CD has to be 4. And since CD is 4, guess what? EF is 4 as well. Why? Because they're all congruent to each other. So the connection here is CD. Since EF is congruent to CD and AB is congruent to CD, they're both equal to each other because they're congruent to the same thing, or in this case the same segment, which is CD. Alright, and AB equals EF. Well, that one has to be true if number 2 is true, just based on the definition of congruent. And that's it. So the answer for this one would be D. All three of these statements are congruent. Right, the last example is just a simple geometric proof. And again, it's a 2-column proof. So the first statement is always given, so we put it for number 1. And what's the reason? Given. Now, if you see here, the last statement is always what you're trying to prove. In this case, they want to prove the measure of angle 10 is equal to 60. And in that case, they put symmetric property. And let's see why they did that. First things first, what is given to us? They're saying that the measure of angle 2 is equal to 60, and they're saying that angle 2 is congruent to angle 10. Well, since angle 2 is congruent to angle 10, I can say that the measure of angle 2 is equal to the measure of angle 10 based on the definition of congruent angles. You can even put the definition of congruent, and that'll be fine. Now that you have that, since those are congruent, we can also, via substitution, we can replace angle 2 with what? With 60. So now we have 60 is equal to the measure of angle 10. And since 60 is equal to the measure of angle 10, we did that via substitution. Then per symmetric property, you can actually flip the statement and say the measure of angle 10 is equal to 60. Because per the symmetric property, if 60 is equal to the measure of angle 10, then you can also say the measure of angle 10 is equal to 60. So this one's really simple. So the only trick here is basically put the beginning and the end, and then from there you can just either work your way backwards, or in this case just forwards is easier, because once you know that they're congruent, if you know they're congruent, they're equal by the definition, and then from there you can just substitute, because it already told you that 60 was equal to the measure of angle 2. And that's how you can prove that the measure of angle 10 is equal to the measure of angle 60. Alright, that's it for this video. See you in the next one.